Get ready for an epic journey to the heart of Venus, the planet that shines like a jewel in the sky, but hides an inferno at its core. Known as Earth's twin due to its nearly identical size, Venus is a cosmic enigma that challenges everything we know about habitable worlds. In this video, we'll dive into its venomous atmosphere, capable of crushing and melting any visitor, explore volcanic landscapes that tell tales of a fiery past, and unravel the mysteries of its bizarre rotation, where time seems to defy logic. We'll investigate how Venus, once possibly a planet with oceans, became the most hostile place in the solar system and what future missions might reveal about its history. With an intense narrative, prepare to feel the heat, the pressure, and the fascination of this world that is both so close and so alien. My grandmother called Venus the morning star or evening star, the popular name given to the planet when it shines brightly at dawn or dusk. This name reflects its dazzling appearance, like a star in the twilight or dawn, a spectacle that has captivated generations. Venus is the brightest object in the sky after the sun and moon, a celestial beacon that never goes unnoticed. This mesmerizing glow comes from its thick cloud layer, made of carbon dioxide and sulfuric acid droplets, reflecting about 70% of sunlight, far more than any other planet. This phenomenon isn't just a visual curiosity, it's a window into Venus's unique composition and a reminder of how sunlight shapes rocky worlds. Its proximity to the sun, at just 108 million kilometers, intensifies this effect, but also defines the extreme conditions that make Venus so different from Earth. Throughout history, Venus's brilliance has inspired myths and legends. To the Babylonians, it was Ishtar, the goddess of love and war. To the Maya, it was Kukulkan, a deity tied to the sky and knowledge. Ancient astronomers like the Greeks observed it with reverence, noting its striking presence at dawn and dusk. Even today, Venus remains a landmark for amateur and professional astronomers, serving as a reference point in the night sky. But its importance goes beyond beauty. Studying Venus's glow helps us better understand its dense, highly reflective atmosphere, which hides secrets about the planet's climate and evolution. For instance, Venus's high reflectivity, or albedo, indicates its near-total cloud cover, which blocks visible light and renders the surface invisible to optical telescopes. This led to the development of technologies like radar, used by space probes to map the hidden terrain. Understanding Venus as the morning star isn't just about admiring its light, it's about recognizing how this planet challenges us to explore the unknown, connecting modern science to the observations of our ancestors. Venus's atmosphere is a chemical nightmare, one of the planet's most extreme and fascinating features. Composed of 96.5% carbon dioxide, it is incredibly dense, with traces of nitrogen and toxic gases like sulfur dioxide. Its clouds, formed of sulfuric acid droplets, hover between 50 and 70 kilometers above the surface, creating an opaque barrier that prevents direct views of the ground. This composition triggers a runaway greenhouse effect, trapping the sun's heat so efficiently that surface temperatures reach 460 degrees Celsius, hotter than Mercury, despite Venus being farther from the sun. This heat is uniform across the planet, day and night, due to intense atmospheric circulation. The atmospheric pressure is equally brutal, 92 times that of Earth, akin to the pressure found a kilometer deep in the ocean. To put it in perspective, a person on Venus's surface would be crushed instantly, and any equipment must be designed to withstand these hellish conditions. But Venus's atmosphere is more than an extreme curiosity. It's a key to understanding planetary evolution. Scientists believe that billions of years ago, Venus may have had a milder atmosphere, perhaps even liquid water oceans. What turned Venus into this cauldron? The answer lies in the runaway greenhouse effect, likely triggered by intense volcanic activity that released massive amounts of greenhouse gases. This process is a warning for Earth, where rising carbon dioxide levels could lead to significant climate changes. Additionally, winds in Venus's upper atmosphere are astonishingly fast, reaching up to 360 km/h in a phenomenon called super-rotation, which still puzzles scientists. These winds move clouds around the planet in just 4 Earth days, far faster than the planet's own rotation. Studying Venus's atmosphere isn't just about understanding a hostile world. It's about learning how planetary climates work, which can help us protect our own world and search for signs of habitability on distant exoplanets. Beneath the clouds, Venus's surface is a breathtaking scene, shaped by extreme geological forces that reveal a living, yet inhospitable planet. Detailed maps, created by probes like Magellan in the 1990s, show a landscape dominated by over 1,000 volcanoes, many larger than those on Earth. Some, like Mount Mons, standing 8 kilometers tall, may still be active, spewing lava and gases that renew the surface. Unlike Earth, where plate tectonics recycle the crust, Venus operates differently. Its surface is relatively young, about 500 million years old, suggesting catastrophic global volcanism that resurfaced the planet in the distant past. These colossal eruptions released massive amounts of lava, forming vast basaltic plains that cover 80% of the surface. Solidified lava rivers, some stretching hundreds of kilometers, snake through the terrain, creating patterns reminiscent of Earth's river channels, but carved by fire, not water. Beyond volcanoes, Venus's surface is marked by impact craters, though fewer than on other rocky planets. This is because the dense atmosphere burns up most smaller meteoroids before they reach the ground, and the existing craters, up to 280 kilometers in diameter, are well preserved due to minimal erosion. Unique rock formations like tesserae, elevated rugged terrains resembling broken plates, suggest ancient tectonic deformations, possibly the last remnants of a more geologically active Venus. Corrosive winds, laden with aggressive chemical compounds, sculpt these rocks, creating dunes and grooves that add a dynamic touch to the infernal landscape. The absence of water and scorching temperatures make this surface an environment where nothing we know could survive. Yet, studying it is crucial. Venus's geology offers clues about how rocky planets evolve without plate tectonics, and comparing it to Earth helps us understand why our planet developed conditions for life, while Venus took such a different path. Venus is a planet of peculiarities that challenge our understanding of time and motion in the solar system. One of its most intriguing features is its retrograde rotation, moving opposite to most planets, including Earth. On Venus, the sun rises in the west and sets in the east, a behavior contrary to what we're used to. This reversed rotation is so rare that only Uranus among the solar system's planets shares a similar trait. Scientists believe this anomaly may have resulted from a colossal impact in the distant past, when a massive object collided with Venus, drastically altering its spin. Another theory suggests that gravitational interactions with the Sun and the planet's dense atmosphere, over billions of years, could have slowed and reversed its rotation. This peculiarity isn't just a curiosity. It profoundly influences Venus's atmospheric dynamics and climate, contributing to extreme weather patterns. Even more astonishing is the relationship between Venus's day and year. A single Venusian day, the time it takes to complete one rotation on its axis, lasts an incredible 243 Earth days. In contrast, its year, the time needed to orbit the Sun, is just 225 Earth days. This means a day on Venus is longer than its year, a nearly unique feature in the solar system. This extremely slow rotation has significant consequences. It reduces the Coriolis effect, which on Earth shapes weather patterns like hurricanes, resulting in an atmosphere dominated by super-rotation, with winds reaching up to 360 km/h in the upper layers. Additionally, the slow rotation limits the generation of a significant magnetic field, unlike Earth, where an internal dynamo creates a protective shield against the solar wind. The absence of this magnetic field on Venus allowed the solar wind to strip away hydrogen from its atmosphere over time, possibly contributing to the loss of water and the planet's transformation into a scorching desert. These characteristics make Venus a natural laboratory for studying planetary physics. Understanding why Venus rotates so slowly and retrograde helps us model the formation and evolution of rocky planets, not just in our solar system, but also in distant star systems. For instance, Venus's rotation raises questions about how interactions between the atmosphere and surface can influence a planet's motion over billions of years. Moreover, comparing it to Earth prompts reflection on the factors that make a planet habitable. If Venus, so similar to Earth in size and composition, ended up with an infernal climate, what protected our planet from a similar fate? Venus's peculiar rotation is more than an anomaly. It's a key to unraveling the processes that shape the destinies of worlds. Exploring Venus is a monumental challenge, but each mission brings us closer to unraveling its deepest secrets. Since the 1960s, humanity has sent probes to face the planet's extreme conditions, where temperatures of 460 degrees Celsius, crushing pressures and sulfuric acid clouds make any mission an engineering feat. The Soviet Union's Venera probes were pioneers, achieving historic milestones. Venera 7 in 1970 became the first probe to transmit data directly from another planet's surface, surviving just 23 minutes before succumbing to the heat and pressure. Its successors, like Venera 13 in 1982, sent the first color images of Venus's surface, revealing a rocky, orange-hued terrain under an oppressive sky. These missions provided critical data on the soil and atmosphere's chemical composition, confirming the presence of volcanic basalt and sulfur traces. NASA's Pioneer Venus complemented these findings in the 1970s, mapping the atmosphere and detecting signs of recent volcanic activity, such as lightning and gas emissions. However, the true leap in understanding Venus came with NASA's Magellan probe, launched in 1989. Using radar to penetrate the thick cloud layer, Magellan mapped 98% of the planet's surface with unprecedented resolution, revealing volcanoes, craters, and tectonic formations that tell Venus's geological story. Its data suggest the planet underwent a global resurfacing event about 500 million years ago, when massive volcanic eruptions reshaped its surface. These historic missions, despite their successes, also highlighted the limits of the era's technology. Most probes lasted only minutes on the surface, and many questions remained unanswered, such as whether Venus once had oceans or if volcanism is still active. Today, a new era of exploration is dawning, with ambitious missions planned to address these questions. NASA's DAVINCI Deep Atmosphere Venus Investigation of Noble Gases, Chemistry and Imaging, set for the late 2020s, will send a probe through Venus's atmosphere, analyzing its chemical composition with unprecedented detail. Equipped with high-precision spectrometers, DAVINCI will search for clues about past water and the evolution of the runaway greenhouse effect. It will also capture high-resolution images of the surface during its descent, focusing on regions like the tesserae, which may hold traces of an older, potentially habitable Venus. Meanwhile, NASA's Veritas, Venus Emissivity, Radioscience, INSAR, Topography and Spectroscopy will use radar and infrared spectroscopy to map the surface in even greater detail than Magellan, identifying signs of active volcanism and studying the planet's mineral composition. These insights will help reconstruct Venus's geological history and understand why it diverged so drastically from Earth. Beyond NASA, other space agencies are joining the effort. The European Space Agency's Envision mission, planned for the early 2030s, will complement Veritas with high-resolution maps and analyses of the atmosphere and surface, focusing on the interplay between geological and climatic processes. Russia is also revisiting Venus with Venera D, which may include an orbiter and a long-duration lander designed to survive longer on the hostile surface. These missions mark a renaissance of interest in Venus, driven by the possibility that the planet may have been habitable billions of years ago. Climate models suggest that early in its history, Venus could have had milder temperatures and liquid water oceans for up to 2 billion years, before increasing solar luminosity and volcanism triggered an irreversible greenhouse effect. The exploration of Venus isn't just about the past, it has profound implications for the future. Understanding how Venus lost its water and became inhospitable can help us predict the fate of other rocky planets, including exoplanets orbiting distant stars. Many exoplanets detected by telescopes like the James Webb lie in habitable zones, but may follow climate trajectories similar to Venus's if conditions aren't right. Moreover, Venus's lessons are a warning for Earth, where rising greenhouse gas levels threaten to alter our climate. Technologies developed for Venus exploration, such as sensors resistant to extreme conditions, could also find applications in harsh Earth environments like active volcanoes or deep ocean floors. The question echoing through all these missions is, could Venus have once harbored life? Even if the answer is no, each piece of data brings us closer to understanding the boundaries of habitability and what makes our own planet so special. Venus, the morning star that enchanted my grandmother, is far more than a radiant speck in the sky. It's a testament to the staggering complexity and diversity of the planets in our solar system, a world that simultaneously mirrors and defies our own. From its toxic atmosphere to its towering volcanoes, from its perplexing retrograde spin to its fiery surface, Venus challenges our assumptions and ignites our curiosity. It stands as a cautionary tale of what Earth could become if we fail to safeguard our climate, yet also as a beacon of hope, pushing the boundaries of human ingenuity through missions that dare to explore the impossible. As we stand on the cusp of a new era of discovery, with probes like DAVINCI, Veritas and Envision poised to peel back the layers of Venus's mysteries, we're reminded that every answer we uncover raises new questions. Could Venus have once been a cradle for life? What lessons does it hold for the countless worlds beyond our solar system? The journey to understand Venus is a journey to understand ourselves, our past, our future, and our place in the cosmos. Drop your theory in the comments, because we want to know what's spinning in your mind. We hope this video has been helpful to you. If you have anything to add or any video suggestions, please share them with us in the comments section. Like and share the video, subscribe, and follow us on our social media, whose links are in the description below. And remember, knowledge is an investment with inexhaustible returns,